A circular coil has 740 turns and its radius is 3.80 centimeters. What must be the current passing through the coil such that the magnitude of the magnetic field at the center of the coil is equal to 0.057 Tesla? Let's directly apply this formula that we derived earlier. This is the magnetic field due to a single loop of radius r with current capital I at a distance x from the center of the loop. And the point of interest at a distance x must be on a line perpendicular to the plane of the loop. In the picture, that's the x-axis. Now, again, this formula is for a single loop only. In this case, we have a coil of n turns, so we need to multiply this by capital N. In addition, we are given the value of the magnetic field at the center of the coil. So that means the point of interest is at a distance 0 from the center. So then x is equal to 0 in this case. Let's rearrange our equation and isolate I and then calculate it numerically. Here we have capital I isolated. So r squared in the numerator simplified the r cubed in the denominator. Also note that I added the subscript to b. I had b0 in the picture, so I have that the same representation in the formula. Now let's go ahead and plug in the numerical values and calculate. We get capital I equals 4.6 amps. The next question is, at what distance x from the center of the coil is the value of the magnetic field equal to half of its value at the center? So we're looking for the distance x at which the magnitude of the magnetic field is equal to B0 divided by 2. Let's reapply our formulas. On the left hand side, I substituted the general formula for B, and on the right hand side, I have 1/2 times B0 from my calculations above. We see that a lot of the variables cancel, so mu0 cancels, I cancels, capital N cancels as well. That's it for now. So let's rearrange and isolate x. So we will have x in terms of r. I did this algebra in multiple steps. So after getting rid of the terms that canceled, so this is, I just rewrote everything after some of the terms canceled. I took the square of both sides and then I cross multiplied. This is what I got, right? And then I took the cube root of both sides to make it, look simpler. And I rearranged, I took the square root again to isolate x, basically. And then when I plug in the value for r equals 3.80 centimeters, I get x equals 2.91 centimeters.